Section 4.3 is about polynomial functions, their graphs, and composition of functions. A polynomial function of degree n is defined by f of x equals a to the n to the xn plus a to the n minus 1 xn minus 1, continue on to a naught, where a naught is a constant. So all the a sub n's are coefficients. And it's important to note that a sub naught doesn't equal 0, and n is a whole number. So if I'm given two functions, then for all values of x for which f of x and g of x are defined, remember their domain, where they're defined, we can add these two functions just like we added polynomials by combining their like terms. So if I have f plus g of x, that's f of x plus g of x, which in this case we have f of x is x squared plus 1, and g of x is 3x plus 5. So I'm going to take f of x plus g of x equals x squared plus 1 plus 3x plus 5. So I combine like terms to get x squared plus 3x plus 6. Now what if I want to find f plus g of 2? So there's two ways I could go about this. First, I could take f of 2 plus g of 2. The second is I could plug 2 into this function. Let me show you how we get the same answer. So if I take 2 squared plus 1 plus 3 times 2 plus 5, see I'm just substituting in for x in f and g. That's going to give me 4 plus 1 plus 6 plus 5, which is 5 plus 11, which is 16. If I was to substitute it in to our original, to the function we found, f plus g of x, let's do that in orange, I'd have 2 squared plus 3 times 2 plus 6. That gives me 4 plus 6 plus 6, which is indeed 16. So we would get the same answer, but one way, this first method, we don't have to first find f plus g of x. We can also subtract functions, right? Remember our functions, they pass the vertical line test. Each x has a unique y. I have given two functions f and g. F minus g is defined by taking f of x minus g of x. So using the same functions we had before, where f of x is x squared plus 1 and g of x is x plus 3, I'm going to take f of x minus g of x, which means I have x squared plus 1 minus 3x plus 5. That gives me x squared plus 1. Then I distribute this negative, so I get minus 3x minus 5. So x squared minus 3x minus 4 is my final answer. Again, I want to find f minus g of x. I could find that by plugging it into f minus g, which we have found. This is our function f minus g of x, and it is still a function. Or I could go ahead and find it by taking f of 1 minus g of 1. And I promise I'll get the same answer. So I'm going to take 1 squared plus 1 minus 3 times 1 plus 5. So I'm going to get 1 plus 1 minus 3 plus 5. That gives me 2 minus 8. I don't know why I put those parentheses in there, but 2 minus 8 is negative 6. Now, what if I was to plug that into the equation I found? I'd have 1 squared minus 3 times 1 minus 4, again with the extra parentheses. They don't hurt, but they're not necessary. So I'd have 1 minus 3 minus 4, which is also negative 6. We get the same answer.